Okay, Saturday, it's been a very loopy day of trying to make tutorials because every time I get into this to demonstrate how it works, I keep thinking of a new idea as a way to try to explain how this crazy push-pop matrix thing works. So I had this revelation came to me a second ago, a way to demo this. So after about 10, 15 minutes of recording, and of course there was another one I did, this is about the third or fourth recording, trying to get something that really works. I digress. All right, so this is the example. I'm going to try to create this by the time we get to the end, but I just wanted to see you to see that I have a couple shapes here. I just have two rectangles, right? And they are moving across the screen, not because they are doing this necessarily, right? There's no like rotate parameter in the rectangle, right? In fact, I haven't even positioned them anywhere other than 0, 0, which would be up here in the corner of the screen, right? But I'm using these new fancy things, push and pop, and I'm using translate and rotate. And I want to show what these are doing. Now, there's good reasons for using translate and rotate, and there are other ways of moving things around the screen, especially rotating using trigonomic functions that are helpful. But obviously the best answer is to be able to use any of these to do what you want to do. So this is the example I'm going to be working towards. I'm now going to stop this and delete basically everything and start at the beginning. So everything that was in here that's kind of new. All right, and I'm going to turn this on and boom. Ta-da! I have a grid. So I've written this custom function just to put some lines across the width and across the height. And just keep in mind, as we look at this grid, this is the representation of the matrix. Right? I'm going to use this to show what's going on the screen. And we're used to this, right? Because we are used to saying, hey, rectangle, 150, 150, and let's make it 150. Oops. I just like 150 today, and we will press play. Right? So here's this on space, right? We're used to moving things around. I'm going to maybe make the fill 220 and 50. So it's transparent. So we can still see our grid underneath there, right? As we start piling things up, and you'll get a sense of this. Oh, and I'm also going to put the background on. All right, so here's where this is in the screen. Let's say I just want to rotate this, and I don't know anything about the matrix or any of this other stuff. So let me create some space here. Let's put this fill. All right, so let's just say I'm going to use rotate. So R-O-T-O-T. And to do this, I'm going to create a variable called R. Let R equals 0. And at the very end, after every time it figures out what R is, of course, the very first frame, it would be 0. I'm going to say R. We're going to increment across this, right? So plus equals, let's do something, just a small number, because we want a slow, gentle rotation. And I'll press play. And you can see, oh, it's off to the races. There goes my rectangle. This is weird. I thought it would just rotate itself. It seems to be rotating from a weird position, right? So that's strange. Let's see, maybe if I, what would be the best way to try this? Let's look at rotate. Let's just put the rectangle at the center. So we're not moving it, we're just going to rotate. So this time it seems to be rotating. It's a little more understandable, but it's rotating again from its corner position, right? So it's rotating here. Let's go up and change the mode that we draw a rectangle, right? So if I say 0, 0, let's go ahead and as the default, the rectangle mode would be corner, right? So when we draw a rectangle, it starts at the corner and we make a width and height, but I want it to actually draw from the center out. So let's just go ahead and press play. And right now it's rotating. It seems to be rotating on itself, so that's better, right? The grid's not moving. We'll come back to that. Let's just go ahead and add a translate here. And you'll see this a lot of time in example code, where because the matrix is situated up here in the upper left-hand corner, that doesn't help us as much when we want to create kind of some center-focused symmetrical composition. Wow, that was a lot of stuff, right? Just the idea that we're going to rotate this from the center of our canvas, and it's rotating from the center of the object, so this is fantastic, right? But the grid is not rotating or translating. It just seems like it's here, and this is important to note. So let's go through the draw and talk about it. So the draw function has to have its own matrix to start with, right? Because you and I have to decide, hey, let's put another rectangle over here at, what was it before? 150, 150, 150, 150, right? Right, so this seems positioned exactly where I told it to, and it's not rotating. So what is going on? So we're going to look at push and pop here in a second. And really the draw has this. It says at the very beginning of draw, let's just have my normal matrix. And I'm going to put a background and a fill. I'm going to put a rectangle here, and it's in center mode, right? So this is 150 units, 150, 150. That's the spacing that I used on my grid down here. And it positioned exactly as I thought it would. And then we got to the grid, exactly what I thought. Now I'm going to translate the matrix over here to half the width, half the height. I'm going to rotate it, and then I'm going to put a rectangle down. And this thing is rotating on itself in the center of my canvas. Maybe what I'll do is add a grid. Right, so really in this sketch, there are two different matrix objects going on. The very beginning, the draw program basically says, I'm going to push, and then I'm going to put everything here, and then I'm going to translate. So this is new, and then by the end, it pops back. It basically resets the matrix to this one. And I can tell that because I can see the grid. Here's the first grid. Here's the second grid. Before any transformations happen, after any transformations. And when I say transformations, that means translate, rotate, and scale. Though I'm not going to use scale here. What would happen if I did? That'd be fun. Scale. Is it 2 parameters? I can't remember. Look at that. It made it 50% the size. Right, so now I have this little windmill. So translate, rotate, scale, grid. What if I put another rectangle down? And let's put this one at, let's again put this one, let's say 400 on the X and 250, what was that? 150, that's right, that's my number, 150, All right, so I have a fixed grid. I have this here. Then I start modifying the matrix. I translate it, I rotate it, I add some scale. I then put a grid down, or a rectangle, then a grid, then another rectangle, right? And this is moving along with this transformation. All these changes here get reflected into this mathematical way of positioning my object. But what if I want to put the grid or the rectangle here? I want to rotate this one, but then this one I want to put in the new location. So finally we will use our commands, push and pop. So this is a way of saying I'm going to begin some new translations or transformations, and here I reset it back to the original. Right? Background fill, rectangle, grid, these here. Now I'm going to push, translate to the center of the screen. I'm going to rotate whatever this number is as it changes. So it's just rotating around. I'm going to scale it. So it now made itself smaller, right? This grid is half that size. And I put down the rectangle, which is at the very center of the screen. What if I put, this will be fun. Let's say that this rectangle on the X is wherever the mouse X is. Right? So what is going on, right? I'm moving my mouse side to side, and this is the mouse X to control the X. So the object itself is not moving in the Y. The world that it exists in is what is moving, right? So in between this push and pop, the world that positions this object is being moved to new locations, right? So this is why the mouse X and Y, the mouse X here is working, right? It's moving in this matrix along the X. It's that it's been scaled down and it's rotating within the push and the pop. And then when I let go of the pop and I put a new object down, it goes back to these new coordinates, right? In fact, let's do this. Rectangle, mouse X. Right? They're both mouse X. It's just the matrix that they currently exist in is different from each other. I love saying that, right? For anyone who's taken an astronomy class, it's not that the light curves around a black hole or a heavy gravitational object. The light travels in a straight line. It's the space that it travels in that is bent. I swear to God, that's the whole thing. That's like the real deal. That's not me making up some crazy thing from the Matrix movie. So this is the whole thing within these translations. You can get a lot of interesting things to happen, but it can get a little complicated. I'm going to pause there. I'm going to come back in part 2 and try to recreate that design. Happy coding.